All right, so we're gonna get started here in just a minute. I just wanted to show you, I rearranged the homepage a little. I think we talked about that last class, but I moved I made a resource tab. And I know they had some stuff further down, but some of the things that folks mentioned, I went and found online after class. So this is the TCC math resource page. And if we just, you can schedule, I guess, your tutoring here. If y'all already know this, I apologize. I think some people didn't. I wasn't quite aware of all this. So you can schedule it, I guess, maybe. It looks like it's maybe for in-person because I clicked on it this morning and they said they weren't there. But if you go down to stats, we're 2023. And there's a lot of things here. I've pulled the things that we need for right now out and put them in. And as the course goes on, I'll pull more of that forward for you. But if you want to see, or if you're ever looking for something, it's here. And there's some videos as well. So when you all mentioned, I think Emma, you told me about the spring video, I found it here. And so I went ahead and just made it easier for y'all to find it all in one spot. So, and I added the one that you sent me as well. So there's the handouts, and I'll go over those in a second, but the videos, the ones that Professor Kennard had made with stat videos are here. The 2021 test review from spring is here. And then the one that they did the other day is here. When I get done today, I'm going to add our link underneath it. Okay. So that way everything's right there, easy to find. The other thing, I'm going to refer to some of these throughout our session today. There are formula sheets, and y'all said you can, you don't have to write things down, right? It said you can print them out. Just make sure it's on the computer. So if you want to print these out, it'll help because like so the symbology, the definitions, these things will help as we go along. So it's got some explanation, sample standard deviation, population standard deviation. And especially later on when we get to some of these formulas and the confidence intervals and different things. But they also have the calculator instructions on here. So if you want to print this out, or if you go to the lab, they said they have copies of all this in person is what Tony had told us in class. And then there's just a separate one for the calculator shortcuts and formulas. And I'm going to be using that because I think it'll help us as we move through, just like to remember how to do these things. Okay. So that way, and as we go throughout the course, we'll keep building on it. This has a nice little formula sheet on here as well. And going back, one more. We have mean, median, mode, and mid-range. It has some good stuff about skewed, because I'm going to be really honest with you. I always in my brain do this backwards. I shouldn't, but I do. So it talks about skewed to the right, skewed to the left. And so it has a good little picture of it to help you, and just like normal symmetric and kind of how those things relate. So I think that's really helpful as well. And it's just got some basic thing with frequency tables. And last, again, there's just a general overall tips. So if you haven't used the 83, 84 calculator before, this is more for like college algebra, looking at the min or max of a function. But it's got like reducing your fraction. That's a really useful one if you need to. Maybe if you can do how to pull things forward, just some basic things. We will be doing factorials. We will be doing combinations and permutations when we get to probability. So some of this will come in handy when we move forward, okay? So I just thought it might be helpful. So I just linked that. And as we go and start doing new things, I'll try and add the ones I think we need as we need them. But that's kind of what I had from that part. So it's on that homepage. I'm going to pull the chat up here. I'm going to switch over to my iPad and we'll get started. Like I said, I'm going to try and record maybe the first, well, maybe we'll just do the whole thing, but I'll record the first 10 and we might take a few minute break. That's good for everybody. And that way too, hopefully everybody can stay with me. It shouldn't take us that long. Take a few minute break, come back, do the next 10, and then take a few minute break, come back and do the last ones, because it's good for all of us, I think. So let me stop sharing this for a minute. Are we good with that? Mm-hmm. Y'all are my rock stars anyway. So, okay, so we're gonna go ahead.
The modules, right? The shortcuts.
Yeah, I put it at the top. I moved the modules. That should be your new homepage. So when you log in, you'll have your announcements at the top, and you should have the modules from now on. I changed it, didn't I?
That made using the calculator a lot easier. Thank you.
Yeah, no, you're welcome. And that's the kind of thing we needed. So I'm glad. I think it'll help us too, because I'm going to pull it up and we'll go through it and I'll show you exactly how to use it. But I want to refer to something that we're all using. So it's not like, oh, hey, push this and you do this. And yeah, so that way everything. Right? Yes, good. And I have the electronic version of it. I think I'm just going to pull it up on my desktop for that part when we get there. But I'll pull it up and I'll do the keys with you and I'll show you exactly how to do that. Okay. Yes, perfect. All right. So give me 1 second. I'm going to pause the recording and we'll start. So come back here and push me off screen. Oh, wrong thing. I was just practicing a little bit to make sure I had it. Okay, so we're gonna start beginning and practice test one, the one I printed out. I used the printout just so that we kind of have the same numbers. And we'll just kind of go through it. The first part, it's gonna be, chapter one, a lot of that, definitions. So if we start with this first one here, we're looking at so we're looking at data given from a statistics class. So the column head gives the variable, and each of the rows represents a student in the class. Give an example of another categorical variable that might have been recorded. So we're just kind of going to go through. So we've got all of our variables up here, and then each of these would be our data, right? What they're asking, so categorical, and we had this discussion in class, and Amelia made a really good point. So, and the way that it was stated in that other problem, so categorical data is what?
Describes something.
Yes, good. It's data that describes like a characteristic is
non-number.
right, and typically it's not a number, describes a characteristic. So a good like default is to say, hey, if it's a number, it may be numerical. Normally,
Yeah.
but
It's something that has no value if you add and subtract it, basically.
right, or like it's nothing that you can just the meaning or the average has no meaning, right? So if we look at, it's not a measurement. That's another way I like to think of it, because a lot of times we're talking about measurements. So like male here, even though there's numbers zeros, that's not something that makes it's either you're a male or you're not. So they use zero typically, I think for not male, and then one is if you're a male, like it's an on-off switch binary. So, but this has numbers, but this is categorical, right? And maybe we should kind of go through some of these. Age, what would that be, categorical or numerical?
Numerical.
Numerical, right? Because that's something you measure, and that's something you can take an average of, or like you can combine them, and find the average, and it has meaning. Anything like this with eye color, those are characteristics of something. So that's pretty obvious because of the words, right? Which is our default, words, categories. Shoe size, again, what would that be?
Numerical.
Or would it be categorical? That one's a little trickier. So that one, I think that would actually be categorical, right? Because you have categories of shoe sizes. So you're not going to measure them.
But couldn't you also like, if it's like, what's the average shoe size of?
You could take an average of it, right?
You know what I mean?
Yeah. You can.
Well, yeah.
I think, yeah.
Because I mean, it does have a unit too. The unit is just US, which I think is like.
And some of them do have
inches,
centimeters.
maybe?
Okay. But do you see how this can be tricky?
Yeah.
A little bit? Yeah, for sure. Now height, for sure, we've got numerical. What about weight?
Numerical.
Numerical. Number of siblings.
Numerical.
Good. And so that could be something where you can have, now does it make sense to have 2.3 siblings?
No.
No, but that tells you, that the mean somewhere between 1 and 2. So on average, people have between 1 and 2. Oh wait, no, 2.3 would be between 2 and 3. Sorry. Now, what about college units as term? What about that?
Numerical.
Good. 1 second. Hey, it's we're working and just stop, please. Okay. Handedness, left or right handedness, that's going to be categorical, right?
Mhm.
Yeah.
The category that we have. So these are our categories. So if we look at what our choices are here, arm span, would that be numerical or categorical?
Numerical.
Good. You measure that. Good. We're done. GPA.
Numerical.
Okay, I think we already covered. We mentioned that. Number of roommates.
Numerical.
Numerical. College units.
Numerical.
And what's left?
Ethnicity.
Which that's definitely a category, right? Okay. So that would be the categorical. Describes a characteristic of somebody. And then if we come down to the data were collected from a statistics class, how many variables are there? So for this one, the variables are what we are measuring, right? The things that we are collecting data on. So what are our variables? I mean, they kind of told us in the beginning, but what do you think?
Male.
Yeah.
Age.
Male, age.
Eye color.
Yeah.
Shoe size, height, weight, siblings, college, handedness. So 9.
So we're just counting how many of those there are, and we would go ahead and fill that in. We've got 9. Perfect. Okay. Are we okay on that? And I'll pause for a second. I'm assuming unless you stop me, but I don't want to go too fast. All right, here we go. So the data in the accompanying table were collected from a stat class. The first row, okay, so the first row here, we'll just stay with this for now. The first row gives the variable. So we know that we've got our variables up here, pretty standard. And the other rows represent the students. So each of these are our data points that we collected. Going back to that, are they female or male that we talked about? They each represent a student in the class. Suppose you wanted to know whether ring size and height were associated. So we're looking for two specific things. We're looking for ring size and we're looking for height. Could you do that using this data table? If so, what variables would you use? So right away, we want to see, what are we going to do? What do y'all think we should do?
Look at ring size and height.
Yeah, so we want to see, do we even take data on that? Because if we don't have data on it, we can't do it, right? So perfect. So I have ring size right here, right? And I have height right here. So if we have these two things that we collected, then absolutely we could compare them and try to determine an association, right? So if we have them, then we can do it. So yes, we can do it first. I'm not even looking at the answers. And then the question, which variable would you use? Well, which variable will we use, y'all?
Ring size and height.
Yeah, those two, right? We'd use ring size and height. So a good thing to do when anytime they have multiple choice is don't look at the answers. I think we mentioned that in class, maybe not. Because sometimes they'll confuse you, the wording, like we said, the words are tricky. So if you come down and you figure out what you think it should be, then you try and see which one matches the closest, right? So the no's are out because we know we can do it. And then this data table could be used, so those are good. Ring size and height would be used. So we would pick B. And then just looking at C, we're not going to use those other ones, right? That doesn't make any sense. So I think if we look at them and try and predict what the answer should be before we select, that's really going to help us. Maybe with some of the trickier ones as well. Are we okay on that? I have a feeling these aren't the ones that y'all had questions about. But if you do, it's okay. We're good. Yeah. And please tell me if you have questions. I'm not trying to rush you, but I also don't want to hold y'all here all day on something if you understand it. This is one that we did in class, I think, but let's go through it again because there may be some folks that need help on it and I don't want to assume anything. So we had a survey was done of men and women's hands to see if the ring finger appeared longer than the index finger or not. Yes means the ring finger is longer. So I'm going to zoom in a little. So if someone said, and I need room here. This is why I practiced because I was writing in place I should. So yes tells me that the ring finger is longer or greater than your index. So that's the length of it, right? No means that the ring finger appears shorter. So your ring finger is less than or equal to your index finger, okay? The students in the survey were not told the theory. So that's good. That means that they weren't given the information ahead of time that men are more likely to have a longer ring finger than women due to more testosterone. Complete parts A through D below. So before we can do any of this, we do need to fill in the rest of the table. And because we're looking at percentages, and for percentages, and I went and I watched some of the videos too to kind of try and make my explanations match up a little bit with what he said. And I said what I said before is good for percent. I kind of like the little bit, what Ross had said about taking percent and thinking about it's the characteristic you're looking for over the total. I'm going to move this so I don't hit it. So you have your characteristic of interest, if you will, and you're dividing it by the total. Now for this one, we do want to be careful because this was the tricky one, right? Because our total's changing depending on what is our subject of interest. So if we come here, we're going to add all of these to get the totals. And then we want to make sure we're using the correct characteristic and then we're using the correct total for it. So men who said yes, this is men who said yes, this is men who said no. Altogether, there were 47 men surveyed, right? So that's the total men. Women, these are my yes women, these are my no. And 49. So altogether, 49, thank you. I'm going to go back real quick. 49. And then here we have 40 and 34. So this is the people who said yes, men and women again. But altogether, I had 74 total yeses. And then below, I had 7 men who said no, 35 no, 15, what did I call? 15 women who said no, altogether 22, right? So we're gonna add down the sides of this, that would be what, 96? Double check my math. I think that's
Yeah.
right. Yeah, thank you all. So what we wanna do first, for part A, and I'm just gonna kind of do these down below, I think, to make sure we have enough room. If we're looking for part A, we have what percentage of the men said yes. So let's maybe change some colors up here. Actually, I want to do this. So I'm going to change.
85.1.
Yeah, you got it. But I'm going to do it just in case, because I think that people that'll watch this later might not get it as quickly as you are. So what I'm hoping that they watch it. So what we're going to do here is put this down a little. So what percentage of the men said yes? So we're only looking at our men column, right? Because we want to know of the men, how many said it. So those are our areas of interest. Those are the people we've identified, and we're going to write it that way. So for this one, we want percentage of men, and then we want the ones that said yes. So we need the men who said yes, and we're dividing it by the total number of men, right? Because men are the group that we're interested in. So for that one, we're going to take our 40 divided by 47. And then what do you got 85.1. Do y'all want me to show you that calculation? You're going to take 40 divided by 41, you'll get what is it, 84 something. And then to put it in percent form, we always multiply by 100. So let me see real quick. And I have more room for so. What did that give you? You said it gives you a decimal, and just go ahead and multiply it by 100 right there. That's the easiest way, 100%. And then we're rounding, like they say, to the decimal, one decimal place. So what did we get? We got 0.084 something, right?
No, it was just 851.
Oh, 851, thank you, I couldn't remember. 851 something, and we multiply that by our 100%. That's going to give, I'll do this for the first one, we'll have to do it for all of them. It'll give you 85.1%. Is that right? What was the number after that? 51. Zero.
Having to round.
Zero. So the zero means we round down. Thank you, Emma. I just want to make sure, because I know there's some folks who maybe aren't as strong on this. So if they're watching it later, I just want them to understand. You want to get to this point before you round. That tells you to round down or round up. So we're rounding down to 85.1. Okay. So that's how we do for each of these. From now on, we can just get the fraction. And if someone needs help with those percentages, just let me know. So what we'll do now is we'll just do a different one. For the next one, we're looking at, what are we doing here? We're looking at what percentage of the women said yes. So women are a category of interest. We're going to be looking here with women and saying how many of the women said yes, right? So this is part B. Oh, let me go back. Well, that's interesting. So part B, percent of women, and that's who said yes. So again, women, yes, over the total number of women. So that's going to equal 34 over 49, right? Multiply that by 100%. What do we get for our percentage there?
69.38, so it'd be 69.4.
Thank you very much. That's perfect. Great. Okay, let me double check that nobody's trying to join us. I want to make sure I'm not leaving anyone out. Okay, I was just double checking. All right, and then I'm going to come down. If y'all see someone's like name pop up, I don't know if it's going to pop up on this screen for me. Can you just let me know? Because I don't want to like not let someone in. I tend to lock the sessions just so that I can see who's coming in, so that somebody who isn't supposed to doesn't. But if you see that, I'm looking down on my iPad. If I miss someone, just let me know. Thank you. Okay, because like I know Tasani was working, he was going to join us late. Part C, what percentage of the people who said yes were men? So we're looking for percentage of people. These are my yes people, right? That were men. So what I want to do there is I want to say, we're looking for men yes out of the total yeses. So that's a different, row and column that we're going to be looking for this time. So if I come here, okay, I'm going to come up here now, And of those who said yes, now this time I'm looking for how many were men. So men's my interest, but I'm looking out of the total yeses. So that's just like the part I think that sometimes trips people up on these. So this one is 40 out of 74. Y'all are already calculating these, huh? Thank you. Okay. So what do we get for that one?
54.05, so 54.1.
Thank you. And then for my last one, this is where, and I was actually really happy because I saw he also did the cross multiplication and setting up the percentage, because that's how I like to do it. So if we come here, last one. So part D is going to take this, and we have to use the fact that now we're using a different number, like a total. So we're given the total, and it's in relation to men. So total men is going to equal 200 instead of the number we had above. If they have the same rate of responses as the men in the sample, how many men of the 200 would say yes? So that's telling us which one we want to use. So we're looking at men and the total yes. So we're going to be using part C for this, right? Because we want to know men yes out of the total, total men. I'm sorry, we're using part A. Can we go back? We're using part A because we're looking for men yes out of men as our total, right? And then it's going to equal our percent over 100, because the percents are, that's what we've been doing this whole time. That's why we're multiplying. We're just doing kind of like a shortcut version up above. So what I'm going to do is I'm going to say we're looking for men. Yes. Our men total has been given. So this is actually the 200, right? Downstairs. This is what we're looking for. This is our variable. And then our percent, we're using what we had above for men yes from part A. Part A was 85.1, right? So I'm going to put that in here. And what we do to calculate this, so I'll make it a little neater. I'll write it right above. If we have 80, I miss my Samsung because it has like a little eraser on the side, so it's a little more natural. If I have, I'm looking for min, yes, right? Over 200. It's equal to my 85.1 over 100. Because percent, again, literally means per 100. It comes from like the Latin for that. Coming here, what we're going to do, we're going to cross multiply to solve. So cross multiplying, you always multiply the two numbers that are across no matter where they are. And then you divide by the one left out. So if I want to know the men who said yes, it's going to equal 85.1 times 200 divided by that 100 that's left over. And I'm sorry if this got a little messy. I can rewrite this on another document if you all would like, but can you read that? Are we okay? Do you see what I did? And actually we could do it up above too. So we know our min yes is going to equal the cross product of 85.1 times 200. And then you divide by the one that's across from the one that we need, the 100. So when we do that, what did we get for our min yes answer?
I got 107 or yeah 170.2, so 170.
Right. And this one was interesting because I wanted to see how they handled it. Round to the nearest whole number is needed. So actually a lot of times in statistics we won't do rounding like normal, but we'll probably handle that later in the semester. Because 170.2, you know, there's not 0.2 people we talked about with children, depending on the context. But we're going to just round like they tell us. So we'll say 170 because it's whole number because you don't have partial people.
So I have a quick question.
Yeah.
I always have problems with these ones because I like try and do it in my head, like the probability kind of wise. So for like the percentage, like I have this like little sticky note that just like tells me like kind of what I need to put where. Could you just like tell me for that one, like what, like how to set that up?
That's exactly what we're doing. Like you, whatever variable they want right here, it's min yes, the number of men who said yes, because that's what we're looking for. That's like our X over the total you were given over the 200. It's always over the total.
Okay, so
And then, yeah. So it's whatever you're, so he kept saying like the characteristic of interest. I'm calling it category, same thing.
okay.
Because they call it categorical data is another way we say it.
I get it. It's just the same thing.
Yeah, it is the same as all the ones above. And really like, let me show you, like, so this one right here, we did this. I'm going to erase a little bit. if we look at the one right here, we did it because what was my percent on this one? This, give me one sec. Like part C, it equaled, what was it? 54.1, right? Over 100. What we really did is, I'm gonna erase the 54.1 real quick. We've been doing this the whole time.
Yeah.
Because we've been multiplying these and dividing by this. It's the same process. Multiplication, division are inverse operations. So you can do them in any order. But what we've been doing is we've been dividing this and then multiplying by the 100.
Okay.
Yeah, so we've been doing this the whole time. So you set it up the same way. What am I looking for? It's just this time they didn't tell us how many were in the what we're looking for. They told us how many were in the total. And we used the percent that we had from above. So this time we had these three and we're looking for the one that we were given each of the times before.
Okay.
Yeah. No, that's a really, really good question. I honestly, like, I really, because you said I feel like you said you weren't good at math at the beginning or something. Did you say that?
That I wasn't good at math?
Yeah.
I'm okay at math. I just like college algebra. I took it in high school and I didn't really have the greatest professor. He went
Okay.
really fast. Like he would never do this. Like he did not slow down for anyone. So
Well, okay, because like I've been kind of using you because you've been asking great questions. And so I was like, I thought, honestly, you've been like my barometer so far. And I was like, okay, Emma's doing okay, we're okay. Because like you've been asking questions, you're getting it. And I felt like, so, but no, you've been doing a great job. And you're asking great questions. So I love it. So keep it up. But that's, yeah, anyway. But yeah, so you got that though, you understand it?
yeah.
Okay, good. And anybody, any questions, please, because anything you ask me will probably help anybody later on watching it. So I'm gonna scoot back out a little bit. Okay, the data were collected from a stat.
Right.
The column head gives the variable. So we have all these variables here again. I mean, we're getting kind of used to that. I think each of the rows is the student in the class. Find the frequency, proportion, and percentage of right-handed people. So we're being asked to find the frequency of right-handed people. So what we want to do, they've kind of given you like this is walking you through the process of creating some of the data that you need from these tables. So let's go for it. Right-handed. So we're going to go to our handedness column. We're looking for how many people are right-handed, right? So we've got 1, 2, 3, 4, 5. So frequency is just how often that particular characteristic or that data value occurs. We have it 5 times. So the frequency of right-handed people would be 5. The proportion. So proportions, what we did above on these. These were proportions. Like when we're looking for the min over the total. And that's what we're doing with the frequency. You're going to, proportion of right-handed people would be number of right-handed over the total number of our total number of people that we surveyed. So
there's 5 over 11.
Perfect, you got it. So that's what goes right here. So you just count it. So we had 5 altogether. We have 11 data points. Thank you. And then for the percentage, you're just taking that, you're dividing it. It's going to give you a decimal. And then again, just multiply it by 100%.
45.45. So 45.5.
Perfect, rounding up. That's a good example of rounding up.
I've got a quick question for the
Yes.
That's that's combining the right-handed and left-handed, and you just put the right-handed over.
Good. Yes, good. Yeah. So what we did is, yeah, we have 5, and then so the right-handed were upstairs, and then
Okay, because I thought I was like, am I doing this right? But okay, I just wanted to make sure.
No, please ask that, because I'm sure somebody else watching it probably is too. So yeah, like you're just counting the total number of data points we have.
And we do 5 divided by 11 for the percentage.
Yep, because you're just taking the exactly, you're taking your proportion and you're dividing it to get the decimal. So it would be like 0.4545, and I'm sure it just continues because anytime you divide by 11, you get these repeating non-terminating decimals. And then we multiply by 100% to give it, just to shift your decimal. That gives me 45.45. We only need one extra place to round it up.
So we put the 5.
Yep,
45.5.
Perfect. And it'll always tell you, it seems to me so far, everything that I've looked at is one decimal, with the exception of like the people, it was having you round to the whole number. But if you're not sure what place, just, always look in your instructions and it'll be there. And that's not for you, that's for everybody. So if I'm saying stuff and you're like, I know, I'm just in case, I'm trying to be as thorough as I can, because I know there's going to be people later on watching it that maybe aren't as prepared maybe as some of y'all are. So yeah, again, so you're gonna divide your proportion from part B. You get the 11, just like you said, that was a great question, by just counting how many total data points we have. We call it the N too, like the number. We're gonna get there eventually. So N is 11, the number of subjects or data points. So we have 45.45 when we multiply by 100. I
So
see
someone's inside the waiting room, by the way.
Yep, thank you. That actually popped up on my iPad. I wasn't 100% sure. How do I? Oh, I'll have to go to on my iPad and do it. But yeah, and then we're gonna round up to get 45.5. Let me
Right.
let you that in real quick, and then we'll keep going. Oh, it's right
Hey,
here. Oh, I bet. Okay, hey Jada, how are you? And I'm gonna move you over. Okay, so we're good on that one.
yes, ma'am.
Thanks. No, and not just you, everybody, but thank you. Excellent. The marriage and divorce rates for a certain region are given over 1,000 people in various years. Okay, and the way it printed was funny. I got confused for a second, so I apologize. Sometimes it's not the best at printing, but this way at least we're all looking at the same thing. So we've been given the marriage and divorce rates. So this table here is the same as the table here. I think this was supposed to, just so we know, because I got confused. And then find the divorce rate as a percentage of the marriage rate and comment on the trend over time. So we want to find these percents first. That's the first part. And then the divorce rate as a percentage of marriage rate over time tends to, and these are the fill in the blank choices for that part right here. Because I got confused when I was looking, I was like, what is going on? So coming here now, let me do some highlighting because I like. Okay, so divorce rate as a percentage of the marriage rate. They're telling you what proportion to use and how to create your percentage. So you want to take the divorce, right? And we're going to divide it by our marriage. And then again, it's a percentage, so we multiply it by 100%. So for each of these, so like 2,000, we'll do that one first. And then after that, I feel like we could probably just calculate them and hopefully folks are okay. So we're gonna start with 2,000 right here, right? The divorce is 3.9. I'm dividing it by the marriage, which is 8.5. And then I'm gonna multiply by 100%. And then it does tell me to round to one decimal place again. So what did we get when we divided that?
You get 0.458, and then when you times it by 100, it's 45.88. So
Okay,
40.9.
let me back up. Actually, that's what you did is perfect. I'm gonna back up and erase a little bit because I don't. What you did was excellent because I don't want people to be like, that's not what my calculation. So you got 0.4588, right? And
Yeah.
then if we multiply by 100%, that's going to give me 45.88. And we need this extra place to round, just like you did. Beautiful.
Mhm.
So I'm going to round to 45.9. Excellent. And that's in percent form. So then we're going to fill that in 45.9. And then we're going to do the same thing going down for the other ones. So do y'all want to do it real quick? Like, Jada, are you there? You good? I don't know if everybody wants to pick one. Who wants to do 2005?
Well, wait, I'm not
Oh.
confused, but I just want to know why, like how you knew. I know it says it in the instructions, but like how you put the divorce over the marriage, like where did you find that at? Because I feel like that's where I get the most confused, like putting
Oh,
where
no, that's
in the
good. Well,
proportion.
because it told me to, because it wanted the divorce rate as a percentage of the marriage rate. So it's telling you that you want the divorce to be, that's the one that we're looking for. And then it's over as a percentage of the merit rate. So of is always kind of like your denominator, but the marriage is like our category of, that's our total
Okay.
rate. So that if we had all these people got married, how many of the, like out of the marriages, how many got divorced?
Oh, okay. Now I'm understanding. Okay.
No, you're fine. And honestly, some of this, it just takes time. And I think it'll come.
Yeah.
Yeah. So like when we're doing it, good, keep asking.
Okay.
Yeah, because it'll have to tell you what they want you to do there. Like that's not something you're just gonna know to do.
Okay.
Right. I mean, because you can use these things in different ways, but that's how they want us to do it in this particular case. So and this is per 1,000 people. So they have, yeah, they took the rate and then they're telling you how to create that percentage. So how many of the people that got married, the percentage they have, how many got divorced? Good. Yeah, and so we're gonna do, and we know to do it for all of them, right? So like 2005 would be the same way. You're gonna take 3.7, divide it by 7.8, and again, multiply by 100%. 2010, same thing, 3.7 over 6.8 times 100. And then 2014. And like, this is kind of weird too, because it jumps years, like, you know, like, I don't know, anyway, I don't like stuff like that. 3.2 divided by 6.9 times 100%. I feel like it should be 2015, but anyway. So if y'all do that, will you give me the numbers? Maybe who wants to do 2005, or did you already do it?
2005 is 3.7 over. I got 47.43, so 47.4%.
7.4. Thank you. Wait, 4.3. Good. Good. What about 2010?
54.41, so just 54.4. And then the last one I haven't done.
0.41 or point, yeah, you said 41.
Yeah.
Okay, I will flip numbers in my head sometimes. I'm sorry, y'all. I'm better at writing things down than listening. 2014, what'd you say? Sorry.
46.37, so 46.4.
7, yep, so that'll round up. Good. So 47.4. Thank you, Emily. Okay. Actually, I'm gonna put it in the little blank. I was writing, just zoomed in, so my writing will be so big. Okay, so 47.4, right?
46.
No, I got 46.4. Yeah.
44. Okay, see, I'm not good at, I always write everything down because I don't always remember things well. Okay, so what we're gonna do, those are our numbers for the part A part. I guess it doesn't label it that way, but it is. If we look here, so what's going on with our marriage rate? So we're going to use this category that they gave us because they want us to comment on the trend over time. So when we look at trends over time, we're looking at what happens as we move from the past to the future, you know, like, so as we go like from 2000, 2005, you know, the rate went down, right? Or no, it went up. I'm sorry, 45 went to 47. So that one went up. If we go from 47 to 54, again, from 2005 to 10, it went up. But what happened when we went from 2010 to 2014?
Decreases.
Yeah, that one decreased. So, and I was looking at this and I was like, okay, because I didn't even see this box down here. I was like, that's kind of weird. So they have this option for you. What does it say? So you can either say it stays approximately the same, that it's increasing or decreasing, or it both increases and decreases. And so that's going to be the correct one for this choice, right? Because we see it's increasing for a while, but then it decreases. So there's not like a trend that continues over the whole time period. So for like a few years there, it looks like it's increasing and then it decreases. So you would pick the both increase and decrease. Does that make sense? Do we have questions on that? Because the interpretation part, I think sometimes is harder even than the calculation part. Are we okay? Everyone's okay on that part? So for this one, then it was the setting up that was hard, just getting that initial, because I know Emma, you said that. And that's really because I think it's the setting up the equation, the solving part most people are pretty good with, and then the interpretation tends to get people, I think. So, okay. So what I am going to do, I'm actually probably going to erase some of this, just so that it's not messy when we look at this next part, okay? But I think it's on screen, and so it won't be in the notes that maybe I send out. I think if anybody needs it, we can always discuss it further. So we're the next few, there's actually quite a few of these in a row that talk about controlled versus observational study. Give me 1 second. I think, let me pause my recording for 1 second or turn my sound off for 1 second. I'll be right back. I don't even know. You know what? Oh, it's on here. Okay, sorry. Just had to ask something real quick. Okay, so here we go. So the next few, we're going to look at observational versus controlled study. So I guess maybe let's just talk about what that means. So observation versus controlled study. Do you know kind of what they talked about, what the difference is between the two of them? Like, what do you understand about observational versus controlled?
You want me to go?
Anybody can go, please.
Okay, so an observational study is something in which no treatment is applied. You're strictly viewing what's happening.
Yeah. go.
But a control, well, but like an experiment or a controlled study has an actual control element to it, and there's actual like treatment being applied. So it's
Right.
not just like an
Yeah.
observation.
Right. And exactly. That's a really good way to. And so like the observation is literally that you're just observing something that just naturally happens. So you're not really changing anything. You're just observing it. And the other thing is the way that they break it out, at least for this text and like for the work we're doing, they talk about random assignment. So a lot of times with the observational, you know, if it's something someone's already doing, you're just observing. And there's no random assignment is a big thing that they talk about in this book. You're not applying it. It's not really experimental because you're not applying, like we talk about like, you know, blind studies and randomly assigning. I would even go so far, we'll talk about the first one there, like we'll talk about in a second. So there's no random assignment. With an observation, they also talk about you cannot like, let me see. There's a word, I just want to make sure I say it right. You can say that there is like, I want to use the right word. One second. So it shows association. It doesn't show causation. Took me a second. The association was not coming to me. So you can say these things are associated. You can't say that it caused this because there could be what they call the confounding variables, right? There could be something else that's contributing to it. He mentioned in that video I watched, it's a really, there is this actually was a thing that happened. It's really poor statistics. They said, and I think it was a newspaper article, I'm pretty sure I found this and I presented to my students in classes. They said, hey, when people, well, his was actually the inverse. So he had one about hot chocolate. I'm gonna talk about ice cream. They said, we've noticed that ice cream, when people eat more ice cream, there tends to be more crime. So that was the one that I've seen before. So that like, and so you can't, and they basically just ask people, you know, like, are you eating a lot of, they notice people are eating ice cream. Hey, crime's increasing. Well, and like what he mentioned with the hot chocolate, it's the same co-founding things. Basically what's going on is people are eating ice cream, it's warm out. If it's warm out, you tend to have people going away from home, you might be summer, you have vacations, there's all these other things, right? And those things all lead typically to more crime. The inverse of that would be, hey, if it's cold, because people typically don't eat ice cream when it's cold. I mean, they do sometimes, but mostly they don't. So there's a decrease in ice cream. And when it's cold, people tend to stay home more. They're not on vacation. Maybe it's like even during when, you know, like school and things, but you also have criminals are also staying home. Like people don't want to go out and like, especially in snowy places, maybe it's going to be harder to break into houses. It's going to be harder to, I don't know, like you have people home. You also have like snow and ice and other conditions. There's a lot of things. So there's all these other things. So that's like, we always talk about like cause, like that something being associated does not mean that it caused it. So that's where like an observation is an association. A controlled study, one of the things is you need that, you have an experiment, you're doing, you have the control of it, but you're randomly assigning your participants. A lot of times it's a blind study, so they don't know what group they're in, if they're a control or if they're part of the trial group. There's also, with this, you can say there's a causation sometimes, right? Like, hey, this links to it, depending on if it's statistically significant or not. So just these are some basic terms and definitions. They will come up a lot more in the future. So, and there's four, I think we have 4 problems here. So we're just going to kind of go through them together. But these are the big things that from this section, I guess it's 1.5 that we want to make sure we get just before we even start. So going through this now. Yeah. So yeah, there's more ice cream, then there's going to be more crime. That's the funny thing. So patients with high blood pressure asked to keep food diaries. So right there, that was to me for a 1-week period. So right away, your group is a certain group of people and they already know they have high blood pressure, right? You're not assigning people randomly, and maybe you are looking at patients with high blood pressure, but you haven't, you're asking people to just do something they already do, right? Researchers analyze the food diary for trends, indicate whether it's an observational study or a controlled experiment. So they are asking people to keep a diary of their food. They're not asking a group to modify it. They're not observing them. They're not randomly assigned. So this one would be what?
Observational.
Observational, good. And we're just gonna think about it before we even look at the choices below. It's observational. And why do we think that? Because we just say it. Oh, sorry.
Oh, because the people are like chosen and it's not random.
Right, yeah, they're just asking folks who are already doing something to do it. There was no random assignment to groups or categories, so there's no random assignment. Good, and so if we know that, then that makes the A, B, C, D choices easier, right? So this one's an observational, so the control's out. So now you're just down to these because there is no mention of random assignment. So, and just be careful, that no is really important. No mention of random assignment. Okay, and I'm gonna pause. Were you all, how did you feel about these questions before? Have you all taken the practice test?
I haven't taken it yet, but I'm gonna take it after this.
No, that's fine. I was just asking.
Okay. Well, if I'm being honest, I was thinking that it was controlled because like when you think of like control, like this is like controlling in a way. I don't know.
But see,
But
they're
no,
not controlling because they're not
yeah,
telling the people to do
yeah,
something. They're allowing them to do what they normally do.
yeah. So
Control
now
example would be like if they said, hey, we're gonna take, this would probably be like your control group if you had it like a normal experiment, because what you would do is you'd apply a treatment, like you would say, hey, we're gonna put, because like one thing with high blood pressure would be putting people on like the Mediterranean diet. That's something that's been shown to like lower blood pressure. So if they put people on that diet and they controlled their food and they had those people, like if they put people on something like that and had them keep a food diary, but like more than just if they asked them to go on a diet and then you had the normal people, right? And then they measured their blood pressure at the beginning and the end. And people, you know, that would be more of a control. It's not a blind one because they know what diet they're on. But yeah, so that would be more because they control what happens.
yeah, this like I'm pretty sure this wasn't in the notes that I like printed out of everything because
Okay.
I just like went because I wrote
He
all
talked about it in the videos. His videos are really good.
Okay, because I wrote down like the control group and like the blinding and double blinding.
Yeah, and honestly, I really think the videos are a little more linked to the homework than even like the notes.
Yeah, so because I just used the notes for like the definitions and everything.
Right. Yeah,
so
no, he did, and they're really short too, because like I was watching while I was working on this just to kind of get a sense of what he said to try and make sure mine linked up. But I mean, what we're doing is fine. I think going forward, honestly, like I said, I think it'd be good if y'all, even if you didn't want to write it down, just listen to the video so you have a sense of what's coming. Yeah, but anyway,
no, yeah, his videos are good.
He is, yeah, I mean, that's Ross. Yeah, he's good. He's, yeah, like I think he's the department chair now, so cool. But yeah, but we'll go through it too. So, okay. And thank you for being honest about missing, like not being sure, because I think a lot of people, it's just, again, one of those things, the more we do it, the better it'll get. Good. Anybody else? Did you all think the same thing? So they're just observing what these people normally do. So because they're just letting them continue with their daily life, that's just going to be observational, and they didn't assign them to a group. Okay. And that was the reason for this one. Let's see. I would also say it might be interesting to look at people who didn't have high blood pressure. That was the other thing, like everybody here has high blood pressure. So anyway, okay. Let's look at number 8, observational or controlled. So a local high school encourages but does not require. So right here, students to wear uniforms. So students self-select here, right? They're selecting whether or not they're wearing uniforms, because it's you know, they encourage it, they don't require it. So everybody's not wearing uniforms if you're selecting to wear it or not. The principal of the school compares the grade point averages of students at the school who wear uniforms with the GPA of those who do not wear uniforms to determine whether those wearing uniforms tend to have higher GPAs. So right away, there are two groups, right? You have students who are wearing the uniform and those who are not. But the principal is but the students are self-selecting into the groups. So, and I right away, I'm thinking, okay, who wears uniforms? Students whose parents make them, number one. And number two, possibly those who have the money to buy the uniform. So, I mean, you could even have like a socioeconomical like spin on this, where like, I mean, if people can't afford the uniforms, or on the flip side, maybe the kids with money buy the really expensive clothes, and the people with less money, maybe they buy the uniforms, because I know like sometimes like Walmart and Target have the uniforms. So there could be a lot of like confounding things here, I think. And then the other thing, and so what he found was like, so the other thing would be like, maybe you see a result. That's what I was thinking too. Oh, no, it's a different one. But so like, sorry, I just got confused. So he compares those GPAs. So what do you think about this one? I kind of just said it, but do you think it's a controlled experiment or an observation?
An observational.
It's an observation because they're allowed to self-select, right? So this one's the assignment as well. It probably would have been better if I didn't look through it because I was thinking of the one below too, what I was going to say. It's observational. And again, it's because they're self-selecting because they're choosing to wear the uniform. So it's observational and there's no random assignment. So it's that same idea. We may want to see if we can pull a few of these if we need to. And then, so I think that's it. So this is, so which choice? This is an
Oh,
observation.
I'm sorry, quick question.
Yeah.
So I'm guessing like most of the tests gonna be like reading, like
That's what I said at the beginning. I'm afraid that because there's so much reading, I think it's where people just get tired. Yeah. There's a lot, but down below there'll be more computation coming up. The first part, we're really trying to like drill the definitions in, huh? Yeah, but there's a lot of reading. I mean, if we go down real quick, because that's a fair question, we start doing more with the graphs and things. So there's a lot of definition-y things, but there's some calculation, but the first two chapters, chapter 1 and 2, are a lot of definitions. We get into the more analytical part when we get into chapter 3. And I left the question identifiers on these, I think. So you can see the test is actually pretty evenly broken up. Chapter 3 is like 18 on-ish. And that'll be pretty similar to the test itself. But I mean, a lot of it, you can see there is definitely a lot of reading. So that's why I said we're going to do like 10, take a quick break, and then come back. The good thing is the practice test is going to be pretty close to the real test, right? So if you're comfortable with these questions and you've seen them, hopefully that means, you'll be familiar. You're not going to see something that you haven't seen altogether before. There's nothing new on this. But yeah, it definitely is going to be a lot of reading. That's why I recommend, doing the practice test, studying ahead of time, and you definitely want to take breaks and make sure you give yourself a good night's sleep, come into this fresh. I mean, you can look over it maybe a little bit, but I wouldn't do this after a full day of like class or after a full day of work because your brain's going to be tired, right? Was that kind of what you were asking? Or did you have a different way you were going with that? I just want to make sure I answered. Okay. So it's observational, right? We said that part, it's not controlled.
We had a joke that in stats that that stats is just AP laying, but
it really
the second
is.
time.
We said that in class about that one, Emma, the one you were asking about earlier. And I think you asked this question in class too. This, to me, this problem, a lot of folks had trouble with it. It was, oh wait, not this one. I'm sorry, number 4, not this one. The problem with this one to me more was like English and the way that we state things than it is with the math. It's like which one goes where. And again, that's English language, but it's also like how you're interpreting that English language in a statistical way. So there's layers to this for sure. But yeah, I know it is. It's very much a language thing, like making sure you're understanding how they're applying the words. And it's very little nitpicky. That I don't love multiple choice. I guess they're trying to help, but.
Are we going to get into writing and experiment design too?
Okay. Oh, Amelia, you're fine. And I will, yeah, and I'll post it, like I said, in there. And then if you have any questions, let me know. Amelia too, if you have any questions when you're going through, if you guys are going back doing chapter 3 or anything, let me know. I'm going to try and get some of those out as well. So I'm going to go back through some of that.
Okay, thank you.
You're welcome. All right, so
One more question.
Yeah.
So is the test open today or is it open up tomorrow?
It's open today. Oh, and I went ahead and gave y'all a week on the test and the practice test. So if y'all want to take it now, you can. If you want to spend a little more time preparing, that's fine too. Because I really recommend, I looked at some folks and I don't remember everybody off the top of my head, but like, because if you haven't got everything up to 100%, that's going to help kind of clarify anywhere that maybe you still have some gaps for everyone. So I'd recommend going back and just starting with like the lower homeworks, anything you didn't get to 100, get it up. That's going to refresh everything. Make sure y'all are taking really good notes and kind of organize it. And then once you get all those up to 100, go back and take the practice test. And then anything you miss on the practice test, go through and see where, you know, maybe those mistakes were, because you'll start to notice like maybe patterns. A lot of times people will have like a gap in like one place or two places or something. And then the question identifiers are on the screen here. And that tells you what section we can pull these, and we can be like, hey, well, maybe I need to go back and review 1.5. And you can even find these questions in your homework or in the textbook. And then we can kind of fix it there that way. And once you feel like you're ready and take the practice test a couple times, you'll see each time you do better. If you have questions, I am going to open class at 8 a.m. Like I was going to tell you all that too. So one of Tasani works, and he's like, well, if you opened it early, I could come in, because I did it last week. I'm going to start doing that just from now on, just to try and help everybody and make sure everybody's where they need to be. So if you need me, I'll probably be there 8 a.m. barring some other commitment, just because sometimes I have meetings. And then going forward, like once you do that, we'll take the test. I am asking that you all submit the scratch paper, because I want y'all to do test corrections, and we'll do it the same way we're talking about the practice test. You know, write down what you did, and then we can go back through and look at, you know, well, you know, maybe I got observational, but I picked the wrong part here, and be like, you know, it was because I missed this or that. And so we can kind of fix it, because the whole idea here is for you to learn and understand. So we'll do test corrections, and we'll talk about the exact format of that the week after Tuesday, because that's when everybody takes it. But if y'all take it early and you want to talk to me about it beforehand, we can. I won't talk about it in class until probably a week from Tuesday, just because that's when everyone's going to be done, hopefully. Does that? Okay. And I'm emailing this out. I wrote it out to someone else this morning about something. I'm just going to use that and format it. So once we're done here, I'll email it out in like words, but that's where we're going. Okay.
Okay.
Okay. Thanks.
All right. Thank you.
You're welcome.
All right.
Okay. So it's observational. The principal does not randomly assign students to wear or not wear uniforms, right? So we know that part. Does not assign a third party. This is different. That would be like something else. But what we're talking about is he doesn't randomly assign. So you're going to pick B for this one. Are we okay on that?
Yep.
Yep. Thank you. Okay, let's go down. A group of educators want to determine how effective tutoring is in raising students' grades in a math class. So they arrange free tutoring for those who want it. Then they compute the final exam grades. So this is the one here we're going to talk about. So they arrange tutoring for those who want it. Then they compare final exam grades for the group that took advantage of the tutoring and the group that did not. So people are self-selecting into this, right? Suppose the group participating in tutoring tended to have higher grades on the exam. You know what I would say to this? This is almost like today, right? And I know people had to work today, but like, or even the people that watch this video versus the people who don't. So if you choose to come today or watch the video, you're probably going to do better on the test, right? But I would say, and this is kind of what they said, those are the people who are already motivated, right? Those are the people who are already working really hard, or the people that have the time to do it. So that's a confounding thing, right? Because you're not controlling and you're not randomly assigning people to groups. So this is going to be because it's an observational. So it says, does it show that the tutoring worked? If not, explain why. And suggest a confounding variable. So that's what they said. And that was what I was doing even before I looked at it. I was like, okay, we know it's observational because they're allowing students to either go to tutoring or not. They're not saying, I'm going to have two classes and one's going to be mandated tutoring and one's not, you know? So it's observational. And then, does this show that tutoring worked? So does it show it? I mean, it does show that tutoring tended to receive a higher grade, right? But it's not a causation. This would be an association. So that's back to the fact that you can only see it's associated. And for this one, the confounding variable would be those who chose to go to tutoring are probably people who, that would be a confounding variable. It may be the people who are already really highly motivated, right? And that's kind of what they said. It's cut off here, but I think that was the answer. If we go down, give me 1 second. The way that it wrote it, and I'm sorry it cut off. It's not the best at printing. So I think it said it's observational. The principal does not randomly, oh, wrong one. And it ran, that was the last one. Because this was observational, it only shows an association. It does not show what the tutoring works. So it shows an association. We can say they're associated, but we can't say that it's caused, like it's saying that caused the higher grades. It could be that more motivated students, because that's what I was thinking, you know, like right away is those are the people who already are probably working pretty hard. So is everybody okay on that one?
Yeah.
Okay, I was just making sure. So yeah, y'all let me know if you're not, right?
Yeah.
Okay, good. Cartilage. Cartilage is a smooth rubber-like padding that protects the long bones in the body of joints. A study by Liu et al. In Arthritis Care and Research found that women who drank 1 glass of milk a day had 32% thicker, healthier cartilage than women who did not. So researchers obtained information on milk consumption through questionnaires and measured cartilage through x-rays. In the article, research concluded our study suggested that the frequent milk intake may be associated with this. Does this study show it? Well, they even used the word here. What word did they use? They used the word associated, right? In their results. So it doesn't show it. It's not saying it's a cause. So they're saying it's associated. They also didn't randomly assign the people. So this one would be observational, right? And so no, we cannot conclude that it shows it. And I don't have the exact words on here again, but you're showing this is an observational because there's no mention of random assignment, right? So no, it's one of these two. No mention. Whoops. See, there you go. I'm getting tired because there is no mention of random assignment. And but it's not controlled, so it's observational. So really that was it. It's the first 4. So we're looking for an observational thing and there's no mention of random assignment, right? Are we okay with that?
Yep.
So I think that maybe they look a little worse than they are. Do you think you feel a little more comfortable in these?
Definitely.
Okay, everybody. Massage, you feel okay?
So I'm right here. Yeah, I do.
Okay. Oh, and I lost Ethan too. I didn't realize. That's okay. Excellent. So I'm just gonna take like a minute. I'm gonna pause this for a second.
So you can take a break if you need to.
Yeah, because I'm gonna drink some water and things because that way and my brain won't get fried and I won't do anything weird.
Yeah, that's fine. I was eating while you were teaching anyway.
What's that?
I was eating while you were teaching anyway.
Yeah, I know my daughter was gonna make food and I'm like, I'm just gonna eat because you know what, it's lunchtime.
Yeah.
Go and eat. Go ahead, shut down.
Yeah, so we'll take a couple minutes and then we'll come back. And if you want to, you could even start the practice test and see how you're going and see how we do at the end. Because I think after we've talked about it, you're gonna see.
Oh, I have a question.
Yeah.
I was doing a practice test last night. I finished on like,
you know what? This is what Ethan
20.
asked me. Did it not give you credit?
Yeah, I'm not sure if it did because like while I was doing it, like the connection, it literally said this question won't be saved. Refresh the.
Okay. We are going to resume. We're gonna do numbers 11. We're just gonna go ahead and try and do the rest of it, 11 through 30 at this point. So I'm gonna switch over to my iPad and cut my camera. All right. So coming back here, we are now going to start with number 11. We're doing some scatter plots.
One more quick question. When it says a plus rate of more than 100, it's not including the 100 itself, right? Just the ones more than 100, right?
Oh, wait. Many sources say should not be more than 100. So I guess they're saying 100 is.
Is it
part A. Okay. Oh, yeah. Okay, sorry. I was just double checking. Yeah, they're more than 100 would be greater than 100. Yeah, because like 100 is included. Yeah, we're gonna do that in just a second. Let's talk about that. So the accompanying dot plot is resting pulse rates for 125 people. So there's 125 dots. What we're gonna do is now we are going to say many sources say the resting pulse rate should not be more than 100. That's a really good question. Not more than means 100 is okay, but anything more than good. Because if 100 is okay, right? But anything more than that is going to be things. It's kind of like in algebra where we have like that open circle. So it's strictly greater than 100. So you don't want anything that is greater than 100. That's a great question. I love that question. So anything less than or equal to 100 is okay in their book. So they're saying, hey, this is okay. So all of these are okay. And it's anything that begins after 100. So none of those dots, those 2 dots are out. We're going to leave them there though.
Okay, so the ones that are on 100, they're not included.
Don't count those. Good.
Okay, I just wanted to make sure because I
No,
didn't
that's a
see those.
really, really good question. That's exactly the kind of thing we want to clarify. So more than 100, we want to start anything to the right of 100. Perfect.
Right.
That's exactly
Right.
it. So we're doing, and let's go through those real quick. Which ones are those? We have 1, 2, 3, 4, 5, 6 of them, right? So we have 6 people who had resting heart rate or pulse rates more than 100. What percentage, Emma, this is your question. You like the percentage. What percentage more than 100? How do we find it? Out of 125 people. So we're going to take our 6, right? Because the more than 100 is our category of interest, like what we were doing in the previous view. So we're going to take the people with more than 100 and put it over the total number that they gave us. So that's our of, just like when we're doing like of men or of yes or whatnot.
So,
So
6 over 125.
perfect, you got it.
Okay, so 4.8.
Okay, and then you rounded for me.
Yeah, it came out to
No, as long as you're rounding, I'm not going to stress because we already discussed rounding,
Yeah.
so we can move on. Nishaj, are you okay on that one?
Yes, ma'am. Yes, ma'am.
And I'm saying your name correctly, yes?
No, sorry. Yes, ma'am. It's just Jason backwards.
I think you told me that and I forgot. I love that. That is cool. The accompanying dot plots show the number of calories in a sample from, okay, and this one was one that was a little weird for me too. So let's talk about it. 2 manufacturers, K and G. Compare the center and the spread, and then based on the sample, which have more variation. So the first thing we want to look at is where is the center? So center, center, center. Oh, you know what I did? I wanted to show you this. I don't like this picture. This is a really bad picture in my opinion. And we're going to talk probably a little bit about truth and statistics, I hope, when we get forward a little more. So you want to make sure that your scale is the same. I understand what they did because you don't want to make scatter plots that are like have things that you don't need. But these two, the scales are different. You see how this is 90 and this is 150, whereas this is 50 and 170. These two are not comparable the way it's written. When I was trying to do this myself, like looking through it, I rescaled it. So I drew, I'm gonna G's up there. I'm gonna bring G down here. Well, I'll just do it below here. I'm gonna make this 50. I'm gonna rescale it. This is my 110. This is my 170. And I just kind of drew it. It doesn't have to be perfect, but just so you get a sense of how they really interact. I'm using the scale from G and I'm going to redo K with it. Okay. Does that make, I might have just said that backwards a second ago. This is 90. So that's 90. This is 100. That's 70. You can kind of see they're listed. Then we have over here, we got our 150 and our 130. Okay. What I'm going to do is all of these dots on this one, maybe I should use the blue on that one. Well, they're both the same color, never mind. So that's 130 and 150. But I'm redoing this one up here. I'm just going to bring it down because 110 is what it has the most of. I'm not even going to count them, but this is like the one that's really high for them. Do you see that? And then their 130, their 120 is a lot. So they have a lot here as well. Do you kind of see how that's all shifted over? I know it's not the best drawing, but do you see what I'm doing there?
Yeah.
Okay, I'm not sure. Because it wasn't, I'm just kind of, and then this one has one out at 140, so that you can kind of see, and then this is 90, that's the 100 has some. So you can see this data is very much narrower than the one below, right? So this is my G below, this is my K. So my K, and then maybe I should have listed it below, but you can see K, like the median of this one is going to be somewhere, you can see that it's going to be lower, whereas this one's going to be higher, right? The one I redrew. Does everybody agree with that? Like the mean of it, not the median.
Yeah.
Mhm.
Are we okay with that, or do you mean to redraw it? Natasha?
No.
You're good?
It's good.
You're good? Okay, good. So that you can see that this one, 110 and 130, so it tends to have higher values. So that's going to be like the mean of that. So you can see right away, K, it's got a greater, the center is going to be greater than the center for G. Yeah. So the center for G is greater than the center for manufacturer K. So we know that it's one of these. They don't have I mean, it's similar, but it's actually it's similar because it's going to be slightly greater, but they're similar. Yeah. Because it's not too far apart, actually.
Yeah.
Okay. They're similar, but they're not so, yeah, they're actually going to be similar. It's greater, but it's not super greater because I'm looking at it. It's the spread that's really different when I look at it. Yeah. So the spread of these two, it's the spread that it's going to be the, not the center, it's the spread. The spread of G is greater than K. Let's put that backwards. And K, the center, it's bigger, but it's not significantly bigger is what I would say. They're going to be kind of similar on that because they're both right in here. They're not too far out. Like if one of them was super far away, it looked like it from the first graph. Sorry, I started looking at the other one again. And then if you look at this, K, the spread of K is a lot less, right? That's much less, I did that backwards, than G. Because the spread of G is so much larger than the spread of K. So K has a lower, so the center for them are about the same. I'm doing the wrong one again. They both have a similar center, but G is not greater. Yes, G is greater. G is greater, K is not. I should have taken my break. So if they have a similar center, and then the spread of G is greater, then what it means is that it has more variation, right? So that's where we're going with the next part. So if we're looking at it, initially they kind of look like they might be further apart if we're looking at the blue, right? But when you kind of put it together, the center values aren't that far apart. They're both right here, somewhere between, one, like, what is that, 100 and 130 for both of them. When I rescale it, most of their data values are in the same area. So the center of their data is in the same place, but the spread is very different when you put on the same scale because the purple ones are obviously, this is much smaller than the other one. So that's going to be part C for this one. No, part A is what I said. Similar center and the spread of G is greater. Yes. And then I made a mess down here. So what does that mean when we talk about the variation? Spread is what represents variation. So spread's another thing we can say for standard deviation or how much the data points differ, right? Like what's the difference between my mean and then the other data points is where we're going with this. So serials from, once again, we said that G has the greater spread because K, when we put it on the same scale, was in here. So if G has the greater spread, then G has more variation because the spread of G is greater than K. So that would be B for that one. Sorry. So their center, when we replotted it, they both were in between basically the same area. But then when you start looking at the variation, this one has data points much larger outside of it. So it has a greater variation in calories. So their serial ranges have a lot of variation. Sorry, that was confusing the way I spelled it. Did you got it now though? I think I confused myself with how messy I made it. Are we good with that?
Yep.
Good. Sorry, I know y'all are probably okay on this. Let me come down. So the BMI, so we have histograms. I would say please refer to those documents I showed you earlier as well. The histograms show the body mass index for 93 females and 85 males. Compare the distributions of BMIs for women and men. Be sure to compare the shape, centers, and amount of variation. All right. So if we're looking at this, we want to look at where the typical values are for these. So we have greater variation here with the women. I would say that. Yeah, everybody agree with that? So like if we look at it, if we brought the women's data down, it has a larger spread, right? So I would say women has a greater spread. And we know that that is an indication of variation, right? So we know that. The shape. So what do we talk about the shape of this?
So women is right skewed.
And that's honestly, that's what I think. I'm gonna tell you something. I think when I looked at it, they said that they thought it was women is right skewed. I think, what do you think about men on this one?
That, I mean, you could also say it's
right skewed. Yeah, this is a little harder. But yeah, I agree with that. So we're gonna check it in a second. So I think they're both fairly skewed because I think your center is about, So let's look at where our center, our mean, and our mode are, and that'll be a way to kind of determine it. So I think that's more of what they're looking for here. If I'm going to be honest, let's go down and let's talk about this real quick, because I want to, let me show you. If we comment down here, so they're talking, yeah, so they're saying right skewed for both. Okay, good. Is this the right one? Yeah. Okay, and then let's come here. Yeah, and then if we talk about the amount of variation, centers, good. Okay, we're good. So both right skewed. Good job. Thanks, Emma. And then we know that we're going to come back and talk about that. The next thing, centers. Where are the centers for each of them? So if we look at BMI for women, where is the center of it? I guess we kind of have that from here, but let's come down. The typical value for women is clearly larger. The centers appear similar. Typical value, centers. So what do we think? The centers for these two. Where would you say the center is for the women, you think? Let's see, we've got how many, again, I'm going to start looking kind of at these. I think, do you think the centers are about the same for the data? I think so, because what I started doing was kind of looking, you've got these two and you've got those two kind of cancel out, and you've got some here. So I think the center of the data is going to be fairly similar for them, because like they're both a little skewed. I think the centers on these two would be fairly similar-ish. Would you be okay on that? What do you think?
Yeah.
I think so. I think they're pretty similar, the center part. But I think the peaks, you've got a bimodal data set right here, right? Like you see how
Yes.
the modes are going to be, you have that, it's got two peaks there. So the women's is unimodal, the men's are bimodal. Is that right? Is it women and men? Okay. And then, so the typical value are of similar, but I would say the peak occurs to do at a higher value. No, let me get rid of that. The typical value for men is larger than women at a higher BMI. So where's the peak for them? What's the one that's the most? So men is about 20, right? So where's the peak for women?
Wait, you mean the peak for women is about 20?
Oh, let me see. Oh yeah, the peak for women. I was looking at which one had the height. 30, I was looking at the frequency. Yeah,
the
so
peak for
men
men
has
is about
24 and
24.
thank you. Yeah. So it's 16 and 24. Thank you. 16 and 24. Because they were saying to compare these things, and then I'm looking at them like their questions
I
are
have a
actually,
quick question. I'm sorry.
yeah,
So like, let me close my door.
you're fine. Because actually the questions are a little different than what they're asking us to look at. So let's look at the questions. Let's go through that.
So when it says left, like I know like on the graph when it's on the left side is right skewed, and when it's on
Yeah,
the left,
and that's the thing, it's the opposite kind of. Yeah.
why is it opposite? I'm just curious. Or just
Because, and that's a really good question. So if you look at like where the mean is, so like the peak is over here, I'm getting, but like say the mean is maybe around here-ish for both of them, or around here, I think, then you've got about 50% on either side. This one has a lot more data out to that tail area, or they both do, actually. Let me see.
also, what does a unimodal and a bimodal look like?
Oh, yes.
I don't know
Okay.
what it looks like, because I'm just
So
like,
this one has like, it's got like two peaks here because it peaks, and then you can see that there's clearly a
so it's
peak.
like when the
There's
bar is,
like a bicycle, there's two of them.
so when it's separate, like when the numbers are, like you see like right there where the how do I right where you're marking, and
Yeah,
where it says the 40 and the where 36 says 40, like the split right there, does that make it bimodal, or am I, or like
we're
what?
looking at the peaks for that because you've got like two modes, like where it's the most. So like,
So it's like the humps in the graph,
yeah,
if that makes sense.
yeah, it's like when you start looking at it, it goes up, it goes down, it goes back
Yep,
up.
like that. And then that's two humps, and then
That-
high, and then the women is just one because it just goes up and then down. And then if it's more, it's like multimodal.
Multimodal, yeah, because you can have more of them, like you can have your data go like
Okay,
this.
so it needs to have one,
Well,
like,
it doesn't need to. We're gonna identify it in the question. So it's possible to have bimodal and then anything greater than that, like what Emma's saying, we're gonna call it multimodal.
am I
but we're-
jumping the gun?
Yeah, we're getting there. We're gonna get there right there. Like it's the second part of this down here. It asks you about it. So they're both right skewed because when you look at where their mean is, so I think the mean, honestly, let's real quick. So we've got how many people? We have 93. So half of that's what, like 45, 46 people. Half of this would be approximately what, like 42-ish. I tend to try and figure out where these things are. We don't have to be perfect, but just get a sense of where you think halfway would be. And then I'm going to do the right skewed thing. Did you get that now, or do you? I'm just going to explain a little more since you asked, so I want to make sure everybody gets it. If you look at, we've got like, I don't know, like it's less than 10. Here we've got 30, and here you've got like 50. So that's going to be about the halfway point, somewhere around in there, right? So this is going to be kind of half the data. But if you look, you have all these frequencies that are way out here that are still occurring, right? So that's why the data is kind of skewed, because you have this great sense of variation on this side, as opposed to this side it's less, there's less buckets, if you will. Do you see that part? And then for this one, same thing. This stuff on this side here is pretty tight together. And then as you come out here, you have a lot more categories going out. That one to me is a little less obvious. I'm going to be honest with you. It is skewed, but it's not as obvious to me. That the one up top is pretty obvious that it's skewed, I think, because of the way it is. And like you said, those two that are way out there, those are almost like outliers, right? And so you tend to have outliers when you have skewed data. But so to me, I mean, honestly, when I first looked at this, you could almost say that's bell shape, but I mean, again, it's skewed a little just because you have some more out that way. Coming here, this one's definitely right skewed, like very, very obviously. But that's why we do these together, and you're not going to have a problem that you haven't seen in class or we haven't discussed on the test. Because some of this is like, but so that's kind of where your center probably is for that one. So if you figure out where it is and you kind of look how much of the data is beyond it, and it's going to have more on this side over here than it did on the other, because it's not symmetric. Like a symmetric bell curve is where you have that nice symmetry where it's basically very, very much even between the two. Does that help, Massage, on that part? On the right skewed, it's more right skewed because you have more things over
More on the left. Yeah, it's more. Since it's more on the left, is right skewed.
Yeah. Well,
That's
since your mean's to the left, yes. So your mean is to the left of it, and so like you have more things on the right side. Like it continues more on the right side. So that's why it's right skewed, even though it's left. Like your hump is on the left, but there's more data on the right. Does that make sense?
Yeah.
No, maybe a little, but that's why it's the opposite. It's because they're referring to it in the sense that there's more data on the right side that's skewing it towards that side. As opposed to,
because it's going left.
Yes. Yeah.
Oh, okay. Because it's going left.
Yeah, because your hump's on the left side, but the data, there's more on the right. Yeah, there's a lot more, there's more data. And this one makes it a little more obvious, I think, because there's a lot more data on the right side of that one.
And for it to be left skewed, it would have
and it would be the reverse. It would be like if you had things over here, right? And you got most of it's like over here somewhere. And so it would be like this, and you still have some stuff here, but like most of your data is like in here, but you have a few things out here that are skewing it to that left side. So your hump's on the right, but the data that's skewing it or that's messing it up is the data on the left. So this one would be left skewed. Is that? Because you have this extra tail, and I didn't draw it out the best. Let me give her that. You have this extra tail. Your tail is over more on the left for that one. And obviously these are not perfect histograms. Does that? Emma, what do you think? Does that make sense what I just said?
No, yeah, I understand these ones.
Okay. And Saj, did that make sense? He may have had to go talk to his building, but yeah, it's where the data that's kind of the outliers and the things that are making it not bell shaped. That's why. And honestly, that actually helped me because I get those mixed up, but that's why, because it's kind of counterintuitive because you think that the hump's over on the left, so it should be left. No, it's right skewed because what's skewing it is the things on the right. Okay.
And the modal,
yeah. The multimodal, let's do that. Okay, multimodal or bimodal. So your mode is the thing that that you see the most of, and it's creating those humps in the data. Like, so if we now take this, now that we have the skew thing down a little, let's talk about our data. If we were just to trace this data, so we trace this up, down, up, and then goes down, you end up having two places where it peaks. And those two, that would makes this bimodal. Whereas this one above, it just goes up and there's a nice flat curve. So that has that one, this is uni, like a unicycle, it's one. So I said, or unicycle, it's unimodal,
Repeat that, like that last one you just said, like that last sentence. I'm so
So
sorry.
like, yeah, no, unimodal is where it's like, there's one, it goes up, it comes back down. It's a nice, pretty thing. There's only one high point. So it's like
With bimodal, there's multiple.
there's two, like a
Okay.
bicycle, like
Thank you.
bicycle
Okay.
has
I
two
was
wheels.
so confused on the
Yeah,
uni.
because bi just means two. Uni
Means one.
Yeah, exactly.
Multi means okay.
Multi, anything 3 or greater, we don't give it special names. We're not gonna say, we could say try, I guess, but we don't really, it's kind of like polynomials. We identify the first few and then we're like polynomial.
Thank you. That
So-
cleared up a lot.
No, good, and that helps me too, because you're helping me work on my explanations too. So I'm good with that. Thank you. And Emma, thank you for your patience, because I know you got this stuff down. So yeah, so we know that this is bimodal. We know the top one is unimodal. We know they're both right skewed. So I kind of filled in the bottom part as we were going earlier, but we'll go over that. But let's talk about our data. So the typical value for them. So let's see the peak of our data. So we have a couple of peak values, but if we're looking at this, the BMI for women is, okay, here we go. This is the first part. The BMI for women is right skewed. It is, women was unimodal. So right skewed. And then I'm going to erase some of this. How did I get this ruler on here, y'all? Oh, I hit ruler. That's awesome. I didn't even know I had that. I'm going to erase some of this so I can see it here. And then this is my right skewed, and it is unimodal. The BMI for men is also right skewed. And this is bimodal, because there's two. So when we drew our little thing, there were two humps. So that's the bimodal. Okay. And so right and bimodal. So you're selecting those from the drop downs or that multiple choice. And then we want to compare the centers and see what we think about that. And then we'll talk about the spreads as well. So let's look at this data and see. So where do we think the center value is going to be for these? So let's look at it. So if we have about, I think about 46 values, I actually tend to find it. And again, Emma, this is where I think having the marks there really helps on these, like what we were talking about in the other. So in the textbook, y'all, I think it may help. The textbook actually put a line for where like the center value would be, or where the mean would be. So if we look at these, I'm going to zoom in too, because these are really small. You've got, I don't know, we can just guesstimate a little. Oh, I'll use a better pencil for this. Make it really fine. Okay. If we look here on these, we've got, what is this? Maybe 2, I don't know, let's say 5. Here we've got 30, right? And then here we're going to have, I don't know, that's over 20, so like 22-ish. So our center on this is going to be somewhere between, it's going to be around 24. It's going to be somewhere it's going to be within the 24 range, right? Because it looks like this clearly goes over 50 people. It's like 46. So it's going to be in here. You're at 24. Where's the center for this one? So we need 42. We've got, I don't know, a little less than 20. We've got 10. And this one's going to be about 20. So same thing. It's going to be 24 is going to be the center of that one as well. So the what happens? So the center, the typical value of them, this is going to be okay, yeah, so the typical value for women is the no, I think the typical value is going to be about the same, right? The 24. Do we think so? But what's going to happen? The summer, yeah, so the centers are similar, but where does the peak happen? Where does the peak happen for women?
At 20.
At 20. So the peak for men happens at what?
24.
24.
So the peak for men occurs at a higher BMI, right?
Yes,
So the
sir.
centers are similar, but the peak occurs at 24. What do you think? Yes.
Agreed. Yeah.
Agree. Okay. Natasha, did you have a question on that one?
If I was answering you said what was the peak for men? I was saying 24.
Well, the peak, what's the peak is the one that has the most frequency.
No, I was answering your question when you said what's
Oh, okay. I'm sorry. Okay.
Oh, there you go.
I thought you were asking me. Okay, you're fine. So, all right. Okay, and then the last one here is going to be compare the spread. So what do you think about the spread? So that's like what we did on the last one. So women clearly has more spread. I think we talked about that at the beginning.
It's because there's more on the right.
Yeah, because they have more. Yeah, they have, and they actually have more on the left too. Like they have this value of 12 that men don't, but they also have values out here. So women clearly have sorry, a greater spread. So the women's values are more spread out. Excellent.
Okay.
Yeah, I apologize, but we worked through that together, so that's good. I think looking for the center, kind of looking, I mean, honestly, that helps me. And they had that kind of clearly indicated in the textbook. And I think that helps. I think it's going to help with the forward example below. Are we good on that one?
Yep.
Yep.
Good job.
Awesome. Thank y'all. Let's go down here. The histograms show the monthly cost for operating two makes of cars, Ford and BMW, which typically has higher monthly cost and which has more variation. And I'm going to be honest with you, again, when we did this in class, and even when I looked at it earlier today, just kind of, I was like, honestly, it doesn't look that different. But what helped again, because I started going back looking at some things. For me, what helps is like actually trying to figure out where the halfway point is. So if we look at it, these are now in terms of relative frequency. These aren't the totals. These are percentages. So they took the number of times something that occurred and they divided it by the total number of data points or the end of the sample that they have. So if we look at this is, I don't know, like 1%, and this is like, I don't know, like maybe 2-ish. So that would be like 3. This, I think we said that was about 7, right? And then this was about 12 maybe. And this is about, I don't know, 4. So let's just see, we got 1, 3, 6. That makes 10, and then that's 14. So 24, 36. And then if you add this, you're going to be about 50%. So I'm going to say the mean's going to be within this bucket right here, right? Like there'll be about half of it like here. And that's just kind of eyeballing. It doesn't have to be perfect, but you want to get a sense of where it is. I know that 50% of my data is going to be less than this, roughly. Okay. Now looking at this one, what do we have? We have about 2, 3. And then here you've got 30 and then you've got 25. So for the BMW, I mean, right away, we know 50%'s got to be less than this, because these two alone are basically 50% of my data, and that's very small. But do you see what happens? Because these don't look that different initially, because I think that's kind of, for me too, a lot of times examples will be kind of cut and dry when you look at them in the textbook and things. But these, what helps is having that line, because what you notice right away is Ford, the mean value, 50% of the values for Ford, it's higher, right? That mean value or 50% of your data tends to be, what's that, 210, 220? This is about 220. This number up here is about 210 for BMW. So what I see is Ford has a larger center, like the center value is going to be higher. So that's going to tell me Ford typically has higher monthly costs because the center of the data is higher than for BMW. Does that make sense?
Yeah.
Thank you. Now so the typical cost is like going to relate back to your center. So this would be the center of my data. That's about the halfway point. Okay. It's not necessarily that it's going to be where half my data is higher or lower. We're talking about frequencies. Now, when we go to variation, we're talking about spread, right? So I do like that these are on the same scale. That was a problem we mentioned with the last one. So this one, it goes from about 110 to, what is that? 3. So that's my 300, 310, 320. So this one, obviously it's gonna be, it's not a very big range, whereas this, it has those values, but you can see there's a much greater variation. We've got something varying from like almost, it's over 300, whereas this is within 200-ish. So clearly Ford has a greater spread. So Ford has the greater spread as well. So Ford has more variation because the spread of the data is greater than for BMW. Are we okay on that too?
Yes, ma'am.
Okay.
And the
Yeah.
we're
I
saying
think-
the standard for BMW is higher, right? Oh wait, no, for Ford, because
Ford, yeah, because that's why I
Even
like
though
to try and find that 50% area, because that helps. Find out where like half the data is less, that's the center. So that helps. So I just kind of looked at these numbers here to figure out, and that's what this line is I drew. I have about 50% of the data less than and greater than that mark. And the same thing here, I have about 50%. It's not perfect, but it helps you see.
but it's,
this-
it's as long as it's like roughly around the area.
Yeah, yes, as long as it's roughly around there. I mean, in this one, you can kind of see you have clearly these two are 50%. So it's basically 200-ish or 210, whereas this one was 220. So I mean, those were pretty close, but it's still Ford is going to be higher.
Okay. Ready.
Yeah, you're welcome. Okay. Let's go here. Suppose a group of school-age children asks, which of 3 ice cream flavors do you like the most? Vanilla, chocolate, or strawberry? Describe a bar graph of their responses that would have the least amount of variability. Also describe a bar graph that would have the most variability. Okay. So if we think about variability in a bar graph, so how many choices do we have for this?
3.
We have 3 choices, right? Good.
Vanilla,
So,
chocolate, and strawberry. Is that 3 choices?
right. And so, right. And so if we have 3 choices, so you have 3 things that they could pick, right? You have vanilla, chocolate, and strawberry, right? So if we think about least variability, what would that look like out of these? If we want to have like if we want to have the least variability, what would that be? So the least variability would be like, hey, if they all like kind of liked one, right? Like say they all pick chocolate. Because there's not very many choices, so it's kind of hard. And then one that, so the bar graph with the least variability would be the one when they favor just one choice, because then you're not going to have a lot of variability between what's going on. Now, the ones with the greatest variability would be one where like you had children liking all of them, right? So
Okay.
So if you wanted to, like, if they all favored one of them, that would have the least variability. But if you had one where they favored different ones the same, then you'd have the most, because what you would end up having is you'd have basically they would like all of them. So like say that all 3 were represented: chocolate, vanilla, and strawberry, right? That's going to have the most variability.
Yes, it will.
Because they're all represented there, right?
It's like its own individual bar.
That would have the most variability because they're all going to be represented on that graph, because those are your 3 answers. So if the only way to make it least would be if they only picked like one, the one that has the most would be if all 3 were represented, and if they all represented it. Does that make sense? Because otherwise you're not going to. Same number of children flavored each, because the variability is going to be different that way. Does that make sense?
Yes.
Emma, were you okay on that one?
Yeah.
Okay. Same number of children flavored each flavor. Okay. Because you're getting the same response, so that on the first one, so that's not variating, but on the last one, if they're all liking different ones, and that's going to be the most variability between the choices. Okay, the table gives information on radio stations for 4 most popular formats. Sketch an appropriate graph of the distribution. So we've got it down here. What I would say is to create this, right?
Do you think that you can scroll over it so I can see what the D is?
Oh, yes, I can shrink it. Oh, actually, it's not on the screen. It didn't print it out. I apologize. We're gonna draw it ourselves, and then we're gonna see which one it matches with. And if it doesn't match with one of these, then I'm gonna say it matches with D. And if D is the answer, we'll have it below. I'm sorry, it didn't print the best. So it's actually not on even the one I printed out. So let's just draw it ourselves. Let's try it. So what we're gonna do is we're gonna make a little chart here. So we start with, I'm gonna use their little things. So they go 0 to 2,500, right? We have 500, we have 1,000, we have 1,500, and then we've got 2,000, and up here we've got 2,500. Okay. Oops, that's supposed to be 500. Oh, that is 500. I did write it. Okay. So what I'm going to do is I'm going to fill in the height. So this one would be format 1 is 2,177. So I'm going to put 1 first, I guess, because that's how they did it. So if it's 2,000, it's going to be in between here somewhere, right? So this would be my format 1. And I guess you could just match them up. I'm just going to draw it for you. Just kind of practice. So I took this class when we didn't have these things. I took this class a long time ago. And we had to do all these things by hand. We actually did a frequency chart with like M&Ms. Like we got that was a fun thing. We got a bag of M&Ms and you had to make the frequency and do the relative frequency for the number of M&Ms, like the different colors. And then the next one, format 2, we'll do. Format 2 was like 1,300. Again, it doesn't have to be perfect. So we're going to do format 2 here. Okay, and that's going to be and then we're going to do format 3 would be 800-ish. Okay. Oh, just kidding. I'm reading that wrong. So let's see, 800 would be around. So see, it's like here. Yeah, I'm sorry I didn't print right. I'll see if I can fix that for the next time. Or I'll try and take a screenshot if I see something like that. And then format 4 is 873. So it's going to be similar, but just slightly less than 3. Okay. So what we can do is, do any of those up above look right? What do you think?
No, I think it might be.
I think it's D, right?
Yeah.
So we'll scroll down here and we'll just double check.
Oh, it is D because C is like flipped of B. Do you know what I mean?
Yeah. Oh no, it looks like it has to be D because none of these are right. So it should have the picture of D there. Yeah. So that's what D looked like in the answers, and that's what we drew. So you've got this nice skewing of the data, right? Okay. So let me come back here. Okay. I'm thinking about something. We'll come back to that in a minute. I'll talk about it. So if you look at it, that one would be D then, which is not the one we have, but that's fine. So picking this one, we're going to pick answer D. We're going to come here. Which of the following would also be appropriate graphs for showing it? Let's see. Which ones do we think would be good?
I think it would be the, how do I say, the Pareto
chart?
Wait. Yeah, the Pareto, the
Okay, so you're saying
bar
Pareto.
chart, and I'm thinking either between dot or Pisto.
So I think a dot plot because of the number of, let me see, just because the number of stations that there are, it would be hard to use like maybe a dot plot and a stem plot just because there's so many data points, right? Because
Okay.
if you have to do all those dots, I mean, look at how many we have. There's like 2,000.
Also, I think you have to have 5, like for a stem plot, you have to have like 5 variables, which we only have 4 of the
Okay,
format.
good. Good. So I think maybe, I mean, a histogram would, so these, we did a bar chart. I think you could do a histogram as well, right?
So A, E, and C. All right. My fault, I don't know.
I'm asking y'all, what do you think?
Oh, I was in a.
You're okay.
I'm
So
going
what
with
do you
that.
think?
I'm going with that answer. A, C, and E.
I
What do you-
don't know if it would be the histogram, just because like the percentages, well, I guess then that's the relative.
But would it
Histogram,
make sense for what we're doing?
grouped in bins to show. No.
No, good. So yeah, let's take the histogram off. Okay. So I think a pie chart maybe would work, and I guess the proto chart would be good.
And also with like just like looking at the bar graph, I have notes that say that there's no gaps in histograms, so
Good. That's what we want. We don't want to have gaps. Excellent. Perfect. And then if we come down, which of the following is the best description of the distribution's important features?
So it's only my fault. So it's only pi.
Pie chart and Pareto for this one. So yeah, what we want to do is make sure that we have the different requirements for all of them written down. And so we can maybe go back through that if we need to. We can maybe make it, that might be a good thing. If we need a video on that, that would be separate though. So like, I think he has videos in the section going over the features of each. So if you don't have something good on that, or if we use the notes from the section, that might be helpful too. Let me see. So this would be in chapter 2, section 3. But if we come to our, and I might switch real quick and show you. There's some really good notes, and you're allowed to print them out. So thank you for going to that review session and her saying that, Emma, because that'll save some folks. Let me make, I'm just going to reclaim the host so that I can share it.
wait, I don't think it didn't say it on the review, but it said it when I was doing the practice quiz.
Okay, if the practice, yeah. So because I just know she told me not the book. We'll pull that up in a second, but if that's what it said on the quiz, we're gonna go with it. I think it's because she just didn't want people to have the ebook up. I think it's just you can't have, and like you can't have PowerPoints and things up on your screen. So let me see real quick. This would be under chapter 2. If we come down and look at some of these notes and the PowerPoints and things, you're allowed to print them out. I would recommend doing that, or just knowing the different things that you have. So if we look at the notes that he provided and just kind of look at what we've got here. Because again, I mean, you don't necessarily have to memorize everything, but you want to understand and know the overall thing so that you can represent it. So, you've got your histogram examples and you want to make sure that it looks proper, just like Emma said. So I would just make sure that, we have these things and we understand how this works for these, because a lot of the stuff from chapters 1 and 2, there's a lot of definitions. Yeah. And then if we go to the PowerPoints, you have that as well. So I would just make sure that when you're going through, a lot of these things are just definitions and knowing what to do. So, and there's a lot in here, but just go through and either print it out and be familiar with it. And so we're talking about numerical data, there's certain ones you want to use when we're talking about. So is this data numerical? So if we're talking about the number of radio stations, what would this be? Because these are asking, it was asking which formats, right?
Yeah.
So if we're talking about different formats, is that numerical data?
That's categorical.
Right. And if it's categorical, then there's certain things that we like to do better, or that we can use that we apply. And so that's where we're going with this. And there's some good information here when we're talking about skewed too. Nasaj, these are really good images to help you, because this is kind of what I was trying to draw, but I'm not like the best at drawing all of that. And there's your unimodal. So I think this will really help. There are multimodal. They talk about, yeah. So mounds, that's a better one. So they don't have to be the same height. So it's not necessarily the peak of it all, but all of these things that we're kind of saying are in the notes. And I'm going to tell you, like we mentioned a minute ago, we looked at the test. There's different problems. So the more times you take the practice test, the better you're going to be. So yeah, so I would just have these things so that you have it when you're looking at it, because you don't have to memorize it. So when we talk about categorical, you know, these are the things, the bar chart, the pie graph, and that's really what we're looking for that. And then Pareto is just like another variation on a pie chart. It's got a little bit additional information. So are we okay on that? Do we have questions? But I would have these things written down, because you don't have to memorize it, but just make sure that you've got the information from these PowerPoints. And yeah, again, making sure that your stuff, like this stuff lines up, some of that. Okay. Yeah, so they're right here. This is what we need for this one. Good.
Yes.
Yes. So like I would make sure that you have that if you don't have that. So if it's numerical data versus categorical, make sure you have that written down. So I'm going to stop this. I'm going to come back over here. Let's finish up. We're nearly done. Actually, Emma, we're going to chapter 3 now, as soon as I finish this one.
Okay, perfect.
So let me take back over on my, because chapter 3 comes after number 18. So I'm going to share content. Let me. Okay, there we go. Now we can do this. I made myself a co-host, so I don't have to keep switching my hosting rules as I move forward. All right. Okay, so coming back here, what is the best description of its most important features? So what do you see with this one? What is the most popular format? Looking at this, what would you say?
Format 1
That one, yeah.
and 2. Oh, well, just format 1.
One, yeah, good. And I mean, because if you want to say most, like I would say, yeah, this one's pretty, yeah, go with format 1. And then if they were, you know, then we would pick it if they were kind of the same. So, but format 1 is going to be the most popular because it's much higher than the other 3, right? Okay, let's go into chapter. Oh, what are Pareto charts? And I actually was thinking
What
about
are-
something else. They're gonna be, what are Pareto charts, y'all?
What are the bar charts?
Yeah, it's gonna be the bar chart that's sorted, right?
Yeah.
So that it shows you the most to least. Yeah, so that it's going to be in order, which ours actually is a proto chart in a way, just because our bar chart just happened to work out that way. But so it's a bar chart where it's selected from the least, most to least. I was thinking of something else when I spoke earlier. I said pie, I meant bar. I'm sorry, y'all. It's another way of rearranging your bar chart. Okay. Are we okay on that?
Yep.
Great. Okay, let's go into chapter 3. This is where everybody wanted to get. So the table below shows gold medal, Olympic times and second. So what we need to do, I'm actually gonna pause real quick just because I want to switch over to my computer so that I can pull up more things. It's hard to do it on iPad with my calculator because we're gonna start doing these on the TI from here on out. So let me pause this real quick.